All right, y'all. So, like I said, 9.4 deals with logarithmic functions. All right, so I'll sort of start out by showing you what a log is, and then we'll look at how to graph these functions, and then actually how to find a logarithm, okay? So let me give you my definition on one of those. So log is shorthand for logarithm. So they come in this form: a log subscript x of y equals b. So here's what's happening. The subscript x is what we call the base of the logarithm. So the base is the number that's being multiplied, okay? The y here, that's what we call the result. So what this logarithm base x of y finds is it finds the exponent that this base x was raised to get the result of a y. So think of it like this. This x is the base raised to this exponent of b is going to equal that result of a y. And it's sort of what I do to check myself is I rewrite it as the base raised to the exponent to make sure I can get that result of a y, okay? So basically, all this logarithm finds, so the logarithm finds the exponent that the base was raised to get the result. So y'all, I'll just show you an example of how to find a logarithm, and then we'll look at graphing, and then we'll get back into finding more logarithms. So let me say I had this, a log base 5 of 25 equals blank. So if I was to find a log, that would be a base 5 that has a result of 25. So basically what I'm looking for, here's my base of 5. It's going to be raised to some exponent there that equals 25. So y'all, what exponent would you raise a 5 to get me a 25?
Two.
Okay, it's definitely going to be a 2. So that means the log base 5 of 25 equals a 2. Okay, so that's all these logs are doing, is just another way to find exponents, okay? So first of all, we'll look at graphing, and then we'll start playing with some more logs like this, okay? And I'll show you a few properties of them. So graphing logarithmic functions. So the first thing you got to realize is that all the graphs go through. So let me ask you this, because I'm playing with exponents. So any number to a certain exponent always equals 1. And y'all, I don't care what number's here. It could be a 5, 1, 3, 14, 50. But if there's a certain exponent that I raise any number to, that'll give me a 1. So what would that exponent be?
0.
That'd definitely be a 0. So since any number raised to the power of 0 equals 1, all these graphs will go through the point 1, 0. Sort of like the opposite of what the exponential graphs. The exponential graphs always cross the y-axis at 1. So they went through 0, 1. These log graphs all go through the x-axis at the 1. And you'll notice all these graphs will have this shape similar to what I'm about to put here. I'm just going out about 4 on this. And what's sort of nice about these graphs, they cross through 1, 0 on the x-axis. So on the left side, they sort of come down and almost do like a vertical asymptote with the y-axis. Now, y'all, it never crosses over the y-axis, but it comes down, sort of trying to get to it, okay? And then on the right side, they just sort of go uphill to the right. Okay, so they'll all basically have this shape, and they'll all go through that point 1, 0, unless we do translations to them. And y'all, in this section, they don't do no translations to you, okay? So your points should all go through that if it's logarithmic. So I'm going to show you how I would graph one of these on the calculator. So they want us to graph. They got y equals log base 3 of an x. Now, I'll say this, the front of your calculator has a log button, but it's a log base 10. So I'm going to have to show you how to get a log like this where we can change the bases on them, okay? So when I go to y equals, to get this log base x, I'm going to go to the math button on the calculator. And I'm going to scroll down until I find log base. Once you click enter on log base, it'll bring up a log with a box blinking for the base, and then a box blinking for the result. So on our example, 3 would be the base, and x would be that result, okay? So let's go graph this on our calculator. So I'm going to share my screen. All right, y'all, so I'm going to go to y equals. So remember, to get that log feature, I'm going to hit the math button, and then I'm going to scroll down until I find log base. Once I hit log base, I hit enter. So remember, my base was at 3, so I'm going to hit 3, and then I'm going to enter to the right and put in my x. Y'all notice now I got my log base 3 of x. So remember, I want to see the graph. So we hit the graph button. Whoops, let me fix my zoom back. So zoom 6. There you go. So if your graph was like my first one, because those were from the problems last week when I had to set my window at -250 and 250. If you want it to go back to a 10 by 10, you just hit this zoom button on the very top row, zoom, and then you arrow down to number 6, standard. And when you hit enter, it makes the graph back to a 10 by 10. Okay. So notice it does go uphill, crosses at 1, 0, and then sort of uphill to the right. All right, y'all. So let me see what they wanted next for us to graph.
My graph isn't showing anything for some odd reason.
So when you hit math and you arrow down, yours does not have the log base on it, right?
It has the log base, but when I hit graph, it doesn't show me anything. It's just a blank graph.
Okay, so let me go up here. So hit the zoom button on the top row. You see the zoom button?
Mm-hmm.
Hit that zoom button and go
Mm-hmm.
down to number 6 where it says standard.
Mm-hmm.
Highlight that and hit enter.
It's still not doing anything for some odd reason.
Okay, it's not giving you any messages?
It's not giving me like like it's giving me a graph, but it's not showing anything on the graph.
Like showing any.
Like line, like how your graph looks now, mine's just blank.
Okay, so let me see. What do you got in your y equals?
Oh, you have to put it in your y equals. That makes sense.
Yeah. So you see mine right now.
Mm-hmm.
So let me clear this and show you how I did this part. So
Okay.
so go to your y equals screen like I did, and
Mm-hmm.
you're going to hit math.
Okay.
And when you hit math, arrow down until you find one that says log base.
Okay.
So mine's A on mine. It says log base.
Mm-hmm.
So when you find that, hit enter, and it'll bring it on the screen.
Okay.
So it's blinking in the first box. That was my base. So we're going to put a 3 there. And then we're going to arrow right. In the second box, we're going to put our X.
Okay.
So now yours should be like mine, saying log base 3 of X.
Yes.
Now, hopefully when you hit graph, you get that.
Yes, I did. Thank you.
Okay. Well, I was wondering what was up because it wasn't giving us a message. All righty. Now, this one they got an f of x equals a log of an x. So y'all, I'll explain this in a second. But anytime there's not a base here, it's assumed to be a 10. That's what we call the common log. Okay, so this is the common log. And that means that a log without any base by it is equal to a log base 10, okay? So this log is on the front of the calculator, so you don't have to go through the math and all that to get to it. So we're going to go graph the log of x real quick. So let me share my screen. All right, I'm going to go to y equals and clear that. All right, so if you see by the 7 here, to the left of a 7, there's a log button. Click the log button, and it brings the log onto your screen. Now, this is, remember, what we call a common log. And since it does not have a base, it's automatically a 10. All right, then we would put in our x. And then if you want to, close parentheses. But y'all, guess what? This graph will look pretty similar to what we just did because they're all going to go through that 1 0 point. So y'all, let's hit graph. And there you go. Only difference is a little flatter to the right side when it's going uphill. But if you notice, it does cross at that 1 0 point still. All righty, and then they had one more. I'm going to show you how to graph real quick. F of x equals the ln of x. Y'all, this is not a capital I. It is a ln. Okay. This is what we call the natural log. Which is ln. Now, when you punch it in the math lab, when you put an L in, it'll make it real bold and highlighted. If you use an I in, it won't highlight it. Okay, so that's how you can tell if you're putting it in right. It makes it bold when you put it into that answer box. Now, an ln or a natural log is actually a log base E. So y'all remember E that we played with the other night? It's the base of our natural logs, okay? All right, and I'm going to do this one just like I did the log. on the very front of that calculator, you will see a LN button. So let's go graph this one. All right, so I'm gonna go to y equals again and clear that out. Right, the LN button is to the left of the number 4 on your screen. So to the left of number 4 is the LN. And you're on the calculator, you hit that LN, and then we put in our X. So I click my X. And then if you want to, close those parentheses. But y'all, guess what? Even e to the 0 power equals 1. So this graph will still go through the x-axis at 1 when we hit graph. All right, here we go. I'm going to hit graph. And y'all, there you go. A little more steep than the one we just did. But notice it does cross that x-axis at 1. All right, y'all. So I just wanted to show y'all a little bit of the graph and before we started finding logs, okay? All right, y'all, so I'm gonna flip this over. So for these examples, they want us to find the logarithm. All right, y'all, so for my first one, this will be number 4 on the problem. They got log base 5 of 125. Now, you can use the calculator. You can go to the math button on the calculator, scroll down, and find log base, and then put in your data. Okay? Put in your base of 5 and the result of 125. But y'all, let me see if y'all can do this by hand. We're looking for the exponent that you would raise that 5 to equal 125.
3.
So that'll definitely be a 3. All right, y'all, the next one, I'm looking for the exponent that I would raise the log base 6 of 36. So how many times you gonna multiply 6 times itself to equal 36?
2.
Oh, I think I heard it, but
2.
2, there you go. And y'all, like I said, if you want to check them, take your base, raise it to that exponent. So 6 squared, well, that does actually equal that 36. All right, y'all, here I'm going to trick you up here. Log base 10 of a 10. What exponent would you raise 10 to get me a 10?
0.
Oh, remember, Jonathan, Alvin, 10 to the 0 power equals 1.
So would it be 1?
So it'll be a 1. There you go.
Oh, okay, I got you.
Yeah, then we told you a curveball on that. And y'all, there's actually a property that goes along with this setup. And that property says the log of any base that matches that result will always equal 1. Okay. So y'all remember that for later in life. If that base matches that result, then you will put a 1 for that, okay? How about the log base 3 of 1 over 81? Now that one, you can punch right in on that log base, punch log base, math, and go to log base. Your base is 3, your result is 1 divided by 81. That should give you a nice number there. But y'all, I'm going to show y'all how to do this one by hand. How many times would you have to multiply 3 times itself to equal 81? So y'all, let's think. 3 times 3 is 9. That's 2 of them. 9 times 3 is 27. That's 3 of them. 27 times 3 is 81. So that was 4 of them. So I'm going to rewrite the 81 using that 3 as a base. And it breaks down to 4. So 3 times itself 4 times will equal 81. So do y'all remember negative exponents any? If I move a number with an exponent up or down, it changes its sign. So y'all, this is going to become log base 3 of 3 to the negative 4th. So I brought the 3 to the 4th up and it makes the exponent turn negative. Is that ringing a bell? I don't remember if y'all did that in foundations or not. Now, check this out. What exponent? So remember, I got a base 3 here, right? I got a base 3. We're going to find that exponent for that base 3 that gives me a result of 3 to the negative 4th. Well, y'all, both these bases are the same. Then that exponent has to be a negative 4, right? I would raise 3 to the negative 4th to make it look like a 3 to the negative 4th. Anytime you get that situation, this exponent is always the answer, which gives us another property. And y'all, like I said, you can punch it in the calculator right here like this, and it should spit out that negative 4 pretty quick, okay? But the property here is if the base of the logarithm matches the base of the result raised to an exponent, then the answer is always that exponent, okay? Because remember, this log A of A part equals 1. So you got an exponent, that becomes your answer, okay? Well, what I like is all these can be punched in that calculator using that log base. All righty, then they play with this. ln of 1. All right, Alvin, now you can tell me. ln of 1 is
0.
0. There you go. Yeah, so y'all, anytime that result here is a 1, then that exponent is definitely a 0. Log of 1 over 10. Now, y'all, what's nice about this? What I'm going to show you on the calculator for this one, you can use the log that's on the very front of it. So let me quit this graphing screen. Since it don't have a base on it, you can come down here and use the log that's by the 7, and then put in 1/10, which would be 1 divided by 10. Close my parentheses. And remember, since that's a fraction, remember a while ago when I had a fraction, I got a negative exponent. So y'all watch what happens when I hit enter. I get a negative 1. So these fractions are always going to give you negative exponents, okay? And then your whole numbers, the results up here like 10, 36, they always gave me nice numbers. But you will get negative numbers when you got fractions like I did on number 9 here and on number 7. Notice that ended up giving me this negative 4 there, okay? All right, y'all, log base 7 of 7 to the 5th. So we know what that's going to equal in the long run, but let me show you on the calculator. Since that's a log base 7 on the calculator, on my calculator, for that one, so let me clear that. I'll hit the math button because it's showing a number for the base. Arrow down to your log base and hit enter. So my base was a 7. And then I'm going to arrow right. My result was 7 to the 5th power. All right, y'all. So whoops. I put too many let me delete that one and then arrow over. All right, so log base 7 of 7 to the 5th. Any guesses?
5.
Yeah, y'all, when you hit enter, you're definitely going to get a 5. So remember, I showed you our property just a second ago. Remember this property right here. When you got a log, if the base matches the base of the result raised to an exponent, the answer is always the exponent. Well, here I go. I got a base that matches the base of my result raised to an exponent. So the answer is always that exponent. All right, y'all, log base 5 of the cube root of a 5. So what I'm going to show you how to do is how to turn one of these radical expressions into what we call fractional exponents. So y'all, here's a little rule from the past. And this will work for any radical. So what I do is I bring my A over. And these radicals are written as fractional exponents. They'll have a 1 on top and then whatever the index of the radical was. So if this was a square root, remember a square root might not have a number here, but if there's no number, it's a 2. So a square root would turn into a to the 1/2. A cube root would turn into a to the 1/3. Okay, so the index is always the denominator on the fractional exponent. So then, y'all, that means I can write this one as a log base 5. 5 is like the a, so you bring the 5 out. Since this is a cube root, my fractional exponent would be a 1/3. So here's the question. Now that I've rewritten this as a fractional exponent, what's the answer? Log base 5 of 5 to the 1/3.
Is it 5 and 1/3 or just 1/3?
Or just a 1/3, there you go. So remember, all we're looking for is those exponents to be them answers. All right, then they'll have another one in a little bit here. Y'all know about this. Log of 10 to the -5th. So think about it. This is a common log. So what base should this be? So y'all remember, if there's not a number shown here for the base, we said that automatically that would be a 10. So you've got a log base 10 of 10 to the -5th. What's that answer?
-5.
-5. Okay, so y'all, you just really got to remember, if I don't have a number here, it's got to be a 10, okay? All right, so log base 8 of 2, y'all, I would probably just run to my calculator. Let me go share that screen. So since I had a log base 8 of 2, I would hit math and arrow down to my log base. Hit enter. I would put my 8 in and then arrow right and put my 2 in. Now, when the result is smaller than the base, you get them kind of numbers from doing like square roots, cube roots, fourth roots. So, watch what I get when I hit enter. Now, remember, MATLAB don't like decimals, so turn that into a fraction by hitting math and then enter twice. And I get a 1/3. So remember, 1/3 is the exponent, so that means you would take a cube root of 8 to turn it into a 2, okay? So when the results are smaller than the base you're starting with, you're going to get these fractional exponents on those, okay? All right, y'all, continuing on. So let me fix my paper. Let's see, I was on number 14 here.
Can you say that one more time? You said when the result is smaller than the what?
So this result of 2, when that result is smaller than the base you started with, the exponent will be a fraction.
Okay, thanks.
Okay. All right, y'all, 14 has log base 23 of a 1. All right, so what's that equal? Oh, and y'all are already taking too much time. All right, Alvin, what did you say a while ago?
0. It's 0. My
0,
bad.
there you go. So y'all, they're just trying to trick you with these bases, but if that result is a 1, you know that's got to be a 0 on those, okay? How about this one? ln of e to the -5th. So do y'all remember the ln? What did I say its base was? It is a base e. So this ln is really a log base e. So you got log base e of e to the -5th. What's that giving us?
I think it's
-5.
Oh, I think I heard y'all say, did someone say -5?
Yes.
Okay,
-5.
that fit perfectly. All right, the last one of these, and then we'll move on doing something else. The ln of the 5th root of e. So I'm going to turn this radical into a fractional exponent. So that's going to give me a ln of e. Y'all, what exponent would I make that?
One-fifth.
1/5. So yeah, it becomes 1 over whatever y'all's little index is there. So y'all remember this, that ln is a log base e. So I got a log base e of e to the 1/5. What's that answer?
1/5.
1/5. Okay, y'all, so they're not too bad. You just gotta play with them and just get used to that terminology there, okay? All right, so next we're going to look at converting from exponential to logarithmic or from logarithmic to exponential. So to use that, here's what we use to cross between the two. Log base x of y equals b, and then y'all want to draw a double-sided arrow. If x, my base, raised to the exponent b equals y. So if I take the base, raise it to the exponent, I get the result of y. Okay? So this little arrow means if and only if. Okay, so remember how these are lined up. So here we go. We're going to, on the first few, we're going to convert exponential into logarithmic. So we're going to convert to logarithmic equation. So y'all, for number 17, they got 10 to the 4th power equals 10,000. So we're going to write log so that we can convert. This is the exponential. We're going to turn it into a log. So right here's my exponential. So if you notice, my base is the x, which is the base of the number being hit with the exponent. So my 10 is my base. So I'm going to come down here and put my 10. The result of my base being raised to the exponent was the 10,000. So you would write your 10,000. And then that equals the exponent, which was the 4. Okay, y'all. So since I had exponential, x became my base, y became my result, and the exponent here became the exponent of the log. So I'll let y'all help me on this one. How about that? So for this one, they're giving me 243 to the 1/5 equals 3. So y'all, you're going to start with a log. What is your base?
Is it 243?
It is definitely 243. My result,
1/5?
well, remember that 1/5 is your exponent. So remember right here, the b became the right side of the equal sign.
Oh, okay.
So the result is actually that
3, my bad.
3. There you go. And then remember the log finds the exponent, which was your 1/5, okay? It's trickier when the results are smaller than the base, okay? But you just gotta be careful with those. How about this? E to the 5th equals R. So here we go. We're gonna write our log. All right, what is my base?
E?
All right, my result.
Would it be 5 in this case?
No,
Or the
remember,
R?
my 5 is still my exponent, member.
Okay, so would it be the R?
It'll be the R. And then that's going to equal,
The exponent, which is 5.
it's
Correct.
going to equal to 5. There you go. Now, it will take this like that, but remember, since this is a log base E, I could do the ln of the R equal to the 5. So if you don't want to write a log base E, remember, you can always use the ln, okay? All right, y'all. So let me do one more of those, and then we'll go the other way. So let's see. This is 20, right? How about this one? P to the K equals 81. Now, y'all, here's the thing. In MathLab, if they use a capital letter, you got to use a capital letter. If they use a small letter, you got to use a small letter. You got to match them perfectly on lowercase, uppercase in your answers, okay? All right, y'all, here's my log. What's my base?
E?
Okay.
Okay, your result?
Okay. I mean, 81.
81, and then that's gonna equal
Okay.
that K. There you go. The reason we're learning how to do this, switching back and forth, next week, when we do 9.6 and solve equations, you got to be able to switch that back and forth, okay, to actually solve those. All right, y'all. So this example, we're going to take a log and convert it to exponential. So we're going to convert to exponential equations. And these start around 21. So we're going to start with a log base 5 of 125 equals 3. So the first thing you got to do is tell me my base. And remember, the base of the exponential is the same as the base for the logarithm. So your base would be the 5. For the exponent, remember the log here found the exponent of 3. So the the exponent of your base is going to be the 3. And that's going to equal your result of 125. Okay, so take the base, raise it to the exponent, that equals the 125 or the result. All right, log 0.1 equals -1. Oh, so the question here would actually be, what is my base?
10.
So it is definitely a 10. My exponent is the -1. And y'all, 10 to the -1 will equal 0.1. So good job. That's what they're trying to get y'all on that one. To see if y'all remember that had a 10 sitting by it, okay? ln of 52 equals 3.9512. So, question again, what is the base of this logarithm?
Was that E?
That is definitely an E. And then bring down your exponent, 3.9512. And that'll equal your result of a 52. So see, they're going to make sure y'all realize that this one has a 10 and this one is a log base E, okay? All right, so y'all try this one. They're not giving me any numbers on this one. They're giving me a log base little m of a t equals a negative y. So y'all, what is your base?
M.
What is your exponent?
-1.
And m to the negative y equals
Capital T.
capital T. Okay, y'all, so 4 doing logarithmic, and then 4 they have you change into exponential. And like I said, that's just to help us next week when we solve these equations. So y'all, let me let y'all catch up real quick, and then we'll pretty much the rest of this is just playing with our calculator, okay? All right. Oh, let me do this. I press hard and my paper starts folding on me. All right, so these calculators or these problems say use a calculator to find a common log. Remember, I told you a while ago, the common log was the one on front of your calculator. And the common log is a log base 10 in all reality, okay? So here we go, 25, they got log of 64. Now, these, when the log is a number that's not like a perfect root of the base, then you're going to get never-ending decimals. So for these problems, they want us to round 4 decimal places. So that's why they was having y'all do that with the E the other day, getting you good at rounding stuff. And they want these rounded 4 decimal places. Now, remember, this is a log base 10. So I'm just going to ask y'all something here a second. Remember, this is a log base 10, and that's the result of 64. So let's just think of something. What is 10 to the first power equal? That equals 10. What is 10 squared equal? That would be
100.
100. There you go. So 64 is in between 10 and 100, those results. So that means your exponent when you're done has to be in between that 1 and that 2. All right, y'all. So let me show you what I'll do to this. I'm going to go to my calculator. Let me clear all that off. So the log button's on the very front. So punch in log and then put in your 64 and then hit enter. Now remember, I got to round 4 places. So the 4th place depends on the 5th place. So I got an 806.1, but my 5th place is a 7, and that 7 is 5 or greater. So we're going to turn the 1 into a 2. So that I get 1.8062. Now, are any of y'all weak at rounding numbers off? Because I can show y'all a trick.
No, but you can show us anyway.
So y'all see the mode button here right on the top? You got that mode button by your blue second button. If I hit the mode button and you see where it says flow, that means it'll put out whatever answer in decimals. But I'm going to go over here to 1, 2, 3, 4. When I go to 4 and hit enter, this will now round me 4 decimal places. So that's what that row's for. Ever how many places you want to round your decimal to. So let me quit that screen. And you see the answer I had. Now that I told it I want to round 4 decimal places, when I hit enter, it gives me 1.8062. Now, after you do these problems, you might want to go back in and reset your mode back to float down here. So go down to float and hit enter. And then it'll go back to the long form. So only use that if you're rounding stuff off the 4 digits. So y'all, since the problems I'm doing now want me to round 4 decimal places, I'm actually going to go and keep my mode on 4, okay? So I'm going to put it on 4 and hit enter and then clear that screen. But after these problems, I would probably set it back on float because future homework might not have us rounding off 4 decimal places, okay? All right, y'all try this one. Log of 2. So y'all round me log of 2 out to 4 decimal places. So let me go back to my paper. So we're doing a log of 2 this time. Any of y'all got a calculator?
Mine says 0.3010.
There you go. So 0.3010. Good job. So let's try this one. Log of a negative 36. All right, so I'm going to show you what that is going to do on here. So let me go to my calculator. I'm going to clear this screen. I had log, so I'm going to hit my log button of a negative 36 and hit enter. And y'all, hopefully y'all are getting something like that. Non-real answer. And if you click 2 to tell it where it's telling me that that number can't be done. So y'all, let's think about that. So remember, this is the base 10. We're looking for the exponent that would give us a negative 36. Well, y'all can't do that, can you? There's no exponent you can put here that'll turn that 10 into a negative number, right? No exponent. Negative exponents will turn it into fractions. Positive exponents will just make it 10 times whatever, how many times. Nothing we can do to turn these 10s into negative numbers. So this is what we call does not exist. Y'all, if your log is of a negative number, no matter what that negative number is, you're going to put does not exist, okay? All right, then they want us to, for these examples, use a calculator. To find the natural logs. And remember, natural logs are the base E logs. So y'all, ln of 53. So remember, the ln button is also on front of that calculator. So we can run up here to the calculator here. Clear that screen. ln is by the 4, so hit ln. And then put in your 53 and enter. Now remember, mine's still set for 4 decimal places. So it looks like I'm getting a 3.9703. Now I'll show you how that would look without being rounded. So say I didn't tell my calculator to round 4 spots. You would have got 3.97029. Remember, the 4th digit is the 2. And since the 2 had a number bigger than 5 or more after it, we had to round that 2 up to a 3. So they'll be playing a few questions doing that. So 29 was the same. So let me show you what 30 did. 30 has the ln of a negative 1.19. So y'all, what's the ln? And the ln's on the front of the calculator of a negative 1.19 going to give us? So it's sort of like this situation. I got a base E. I'm looking for the exponent that I can raise the E to get a negative 1.19.
Doesn't exist.
Yo, it does not exist. It's going to give you the same error we got up here because I can't turn an E, which is a 2 point something, into a negative number. So y'all, this one also will be does not exist. And they'll have a choice B that says the solution does not exist on those, okay? All right, then it says find the logarithm using change of base. And y'all are giving me, this is 31, they're giving me a log base 6 of 18. And y'all, these ones we're going to round 4 decimal places also. So here's my question, because on this one, I would use that log base that I showed you. But my question is, does anybody have a calculator that does not have that log base on it? So remember, I would go to math and then down to my log base. Now, if you're using a phone app calculator, they will have that on it. So y'all, let me show you. Back in the day, we didn't have this log base feature. So the way we had to find the answers to problems like this was using this change of base. So what change of base does is it takes the log of the result, which would be the log of the 18. And then you would divide by the log of the base, which would be the 6. So doing log of 18 divided by log of 6, I would get the same answer that y'all would get when you punched in log base 6 of 18 using the log base. So let me show y'all that. So I'm going to go to my calculator. So let's see what the log base would give us. If I would hit math, arrow down to the log base. And I had what, a base of 6 and a result of an 18. So y'all doing that? Now rounding 4 decimal places, that would have gave me what, a 1.6131. I would keep that a 1 since that was a 4 after it. Now y'all watch what other way I said. The other way was to change a base, which would be the log of the result, which is 18, close parentheses, divided by log of the base, which was 6, close parentheses. Y'all watch that. When I hit enter, I get 1.6131, just like I did doing the log base. So, yeah, back in the day, that's how we had to do these. So 6131. So yeah, back in the day when you didn't have this fancy calculator, you had to take the log of the result over the log of the base, okay? All right, so let me just show you one more of these. How about a log base 3 of 70? So log base, I would do the log of 70 divided by the log of 3. Now, easiest way would be to use my log base, punch in a 3 and a 70 and be done. But y'all, either way on this, I think you should get a 3.8671. All right, so y'all 33 and 34 doing the same thing with this. But like I said, you can pray with this if you want to learn it that way, or you can do your log base on your calculator, okay? So the last thing they wanted you to do on here for this 35, they say graph both functions using the same set of axes, using the same set of axes. So 2 graphs on 1 picture, basically what they're saying. So y'all, my first one, they're giving me f of x equals 2 to the x. Now we know these graphs we learned the other day. These little graphs, they cross at 0, 1 on the y-axis, and they sort of came along, crossed at 1 and went uphill. On the second one, they want me to do, now they're calling this f negative 1 of x. Remember, that's the inverse notation we learned back in 9.1, I think it was. Because the logarithmic graphs are actually inverses of the exponential. So this one, they want me to graph a log base 2 of x. Because see, there's my base 2, so I'm going to draw a graph of the log and a graph of the exponential. Now remember, the log graph we just learned when we did logs, they crossed the x-axis at 1, 0 here, and they sort of came up, crossed, and then went to the right. So what I'm going to do this one, I would do y1 equals 2 to the x, and then I would come down to y2 and make it a log base 2 of x. Or now that y'all know change of base, remember this one could be the log of x divided by the log of 2. But that's more work. We got this feature now, so let's go knock this out. All right, so I'm going to y equals, and I'm going to clear off the old stuff. So my first graph was 2 to the x. So I got 2, and then my exponent was the x. Then I'm going to go down to y2 down here. And my second equation was the log base 2 of x. So I'm going to hit math and go down and get that log base. Hit enter. And then my base was a 2. And my result will be those x's. All right, y'all. So I got my 2 y's plotted. So now all we do is hit graph. And then we would choose one of our 4 pictures. And y'all, you see that graph, right? That is exactly the 2 graphs that we had a while ago when we was looking at our basic pictures here. So if I was to put both of these on one axis, so here was my 0, 1 and my 1, 0. So this one looked like it was going up, and this one came in and looked like it was going that way. Which models these 2 pictures that we had for those, okay? So y'all, this was number 35. And that was our last question. They just wanted y'all to see how using the same base looked on these problems, okay? All righty, y'all, and let's see, 9.4 is another section that did not have a support lesson. The next support will be on 9.5 when we do Monday, okay? So y'all, I'm to the point. Do y'all have any questions over the logs? And really, most of this today is on that calculator, right? So get familiar with your calculator on these, and this section won't be no problem for you, okay? All righty, let me see on my chat. Nah, nothing on chat. So I'm going to stop our recording here.